or evening, depending on where you are, and welcome to our energy exchanges. We appreciate your presence here as we embark on an exciting new initiative, Energy Exchanges at eClay. I'm Sastri, Senior Officer, Sustainable Energy at eClay World Secretariat, and I will be moderating today's Energy Exchange. Today, we will look at how our efforts can support cities, regions, and local governments in their sustainable energy transition. Next slide. Today, we work with a strong network of over 2,500 local and regional governments. We will explore how we can provide support across a range of development pathways in line with eClay's focus areas, from low emission development to people centric and circular development. Next slide. We are now delving into the foundational aspect of our flagship work on achieving 100% renewables. Our collaborative efforts extend to numerous cities and regions where we assist them in making the transition from their current energy status to achieving 100% reliance on renewable energy sources. This endeavor aligns with and endorses the definition of 100% renewables as set forth by the IRENA Coalition for Action. Next slide. Our collaboration extends to cities in both the global north and the global south. We are actively engaged in helping these cities develop their localized strategies and roadmaps. Our focus is on identifying the necessary elements of local policy development to facilitate these strategies. We also ensure that these policies are effectively aligned with implementation mechanisms. This harmonious integration not only drives the development of bankable renewable energy projects, but also promotes multi governance and builds the capacity of different stakeholders. Next. The entire journey from initial planning to successful implementation encompasses several crucial stages. Among these stages, a pivotal point emerges where we must bridge the gap between action and planning. Next slide. Today, in our energy exchange, we want to focus on a specific topic. The reason for this exchange is to facilitate bridging the gap between action and planning, taking into account the unique local context. Throughout this series of virtual exchanges, we will provide in-depth insights into solutions that are well suited for local sustainable energy transitions, which is aimed for local government practitioners and experts in the field. Next slide. Next slide, please. Yep. As I mentioned above, today is the fourth in our energy exchanges series, and we are diving into a fantastic topic, heating and cooling from wastewater. In this energy exchange season, we will explore the untapped potential of harnessing energy from wastewater. Thanks to the European Union Directive 2018 by 2001, the wastewater is now recognized as a renewable heat source. Whether from the domestic or industrial or commercial sources, wastewater retains a significant amount of thermal energy as it travels through the severe system. Innovative technologies such as heat exchangers and heat pumps offer a practical solution to capture this energy and use it to meet the heating needs. Ultimately, our discussion today highlights wastewater heat recovery as a robust, sustainable source of clean energy. It has the capacity to provide environmentally friendly heating and cooling solutions for communities, neighborhoods, and even entire buildings. Next slide. Today, we have a special guest to discuss more on wastewater heat recovery. Please welcome our featured expert, Mr. Christian. Christian von Drachenfels is responsible for the business development of energy from wastewater in Europe at the Uhrig Group. Previously, he was head of the business unit, environment and sustainability at DLR Project Tracker, senior consultant on innovation policy at VDI Innovation Plus Technique. and researcher on economic development and innovation systems at the German Institute of Development and Sustainability, IDOS. With that introduction, I am going to hand over the virtual microphone over to Christian.
Thank you, Sastri. Thanks a lot. Good morning to everyone. Good day, good evening. And as I understand, this thing is going to be recorded. So greetings to the future. I hope it all finds us well if you're looking at this in the future as a recording. Yes, thank you. Thanks for the invitation. I would like to share a bit about our expertise, our knowledge on using energy for heating, energy from wastewater for heating and cooling today. I prepared a presentation to do this, and I'm already seeing some familiar names in the, hope you can you see this correctly now?
No, could you
like
please?
Is this
Yes, now yes.
This way. Okay,
Correct.
okay. Yeah, as I said, I'm seeing some familiar faces among the audience, and I know that these people are experts on the topic as well. So very good to I hope this is going to be a fruitful discussion anyway afterwards the presentation, and therefore I'm trying to be quick here. Yeah, just as a short introduction on what's my background, and what's more important is what's the background of the company I'm working for today. Is that as Sastri said, I mean I did some work in international development cooperation and international economic research, and then I was responsible for R&D support programs Germany, and since a couple of years now I'm working for the Uhrig group to develop energy from wastewater projects, and this is what this company has been doing since 2007. It's a civil engineering company. Is still doing a lot of sewer construction, sewer rehabilitation works in urban areas throughout Europe mostly. But since 2007, the company is involved as well in the topic of energy from wastewater, developing projects in Europe as well in the United States and in Canada. And we have completed more than 120 projects by now. So it gives us experience on the topic with these projects. Our oldest systems are in operation for some 15 years, a lot of practical experience gained here as well. And our business focus is always is the public sewer network, our treatment plants and the wastewater infrastructure. We're looking at supplying buildings or heat networks. The plant sizes usually they are some starting at 15 kilowatt extraction of energy from the wastewater up to many megawatts. And this is what I will talk about today as well, about the public sewer network, the public wastewater infrastructure, including treatment plants. So quickly, just what's the interesting story of energy from wastewater? Well, we always say it's almost an unlimited availability of wastewater as a renewable energy source, because if you think about the vast network of sewer infrastructure, wastewater treatment plants, I mean, this is one of the key infrastructures of our civilization, as well as roads or freshwater pipes or electricity or whatever. Usually where there is civilization, where people are creating cities or building cities and so on, they are thinking about installing a wastewater infrastructure as well. So this is a large infrastructure that's already there and can be used for heating and cooling purposes. And the interesting thing is why it's interesting. It's because wastewater, the temperature in winter, I mean, I'm talking now very much from a German or European perspective. It's true for other parts in the world as well. I will explain a bit more later about this, how you might look at this temperature issue and if you're in other parts of the world. But in Germany, and especially, it's like in winter, the wastewater still has a temperature of 10 to 12 degrees that is flowing in the system. In summer, it's approximately 17 to 20 degrees. It varies from city to city. It's depending on specific factors, like if there is a lot of industry that is discharging wastewater, hot wastewater in the system, of course, you can find higher temperatures and so on. But let's take these rough numbers as an idea. And then you understand that you've got a comparatively warm resource in winter. If you are tapping this, let's say maybe just 10 degrees warm I wouldn't say hot, but warm wastewater. If you're tapping this energy with a heat pump, it's of course more efficient than if you would use the air, which is maybe just 1 degree, 2 degrees outside. So this makes wastewater an attractive and efficient resource for using it with a heat pump in winter. And in summer, if it's some 30 degrees outside, if it's hot and you want to cool, then you can think about using the wastewater stream as a heat sink. You're basically, I'm not an engineer myself, so excuse if I'm saying this in very simple words. If you turn around the system, the heat pump system, and if you're using the wastewater stream as a heat sink, you might use it for cooling purposes as well in buildings or in the cooling network or whatever. So yes, I mean, this is what I said. This is a bit like a very rough idea of a temperature curve that you might find in Germany in the wastewater infrastructure at a given place. Of course, I know it's different in the southern hemisphere. It will look more or less the other. It looks like the other way around. You have winter in June and July and August, so temperatures will look different then. Finally, if you're in a tropical climate, I mean, I have to admit that I'm not an expert on the wastewater infrastructure in general and around the world. I read now about it, how it looks like in Germany, how it looks like in Europe. But it's possible to find out in any given location, wherever you are, what the temperatures are in the system, and then you can see how it looks like for cooling and heating purposes. Where is there an attractive difference between the temperatures that you have outside and that are in the rather constant temperature level in the wastewater that you find there. So I just wanted to indicate this here very roughly. It's important to look at the infrastructure locally. It's important to check what are the temperatures of the wastewater in the system, and then see if you can identify efficient opportunities to use it for heating or cooling purposes. And this is, again, the story of energy from wastewater continued. I mean, as I said already, it can be used for heating and cooling. I mean, there's a figure now, this is just for Germany. It's always difficult with these figures, how much of a given energy resource can cover how much of the demand. I mean, these are figures that usually you can get from studies, but all studies are making some assumptions. So this explains why there is usually a variety or a certain spread of what's a given potential of a specific source. Could be geothermal, could be biomass, could be wastewater here now. But at least the studies that we have for Germany that are indicating that there could be a potential of 5 to 14 or 15% of the heat demand in the building sector in Germany that could be covered with energy from wastewater. I mean, this is, as I said, I wouldn't say that we should be very specific about these numbers. But in general, what all the studies are indicating is that energy from wastewater has the potential to be a significant part of the solution for the future green heating and cooling in Germany, in Europe, in the world. So we shouldn't overlook this potential. This is what I want to stress here. Energy from wastewater, or wastewater as an energy source, is of course particularly strong in urban areas. Obviously, because there is a lot of wastewater, because there are a lot of people living in urban areas. There's a lot of wastewater in the infrastructure. Where there is a lot of water used, there will be a lot of wastewater. And the good thing about this is that usually this falls together with the demand for heating and cooling as well. So in that sense, wastewater can be seen in many cases as a very local sustainable resource for heating and cooling. And the good news is that it's already competitive. We see this in the projects we are doing. We see this in the projects that other companies are doing and energy companies are doing. Many cases, it is a competitive energy resource. Of course, not always. In some cases, in some locations, other sources will be more competitive. but it's the good message is it is already competitive. Therefore, it's quite interesting to see that this whole market, I would say, is still in a very, very early stage. I mean, we as a company are operating in this market for about 15 years now, others as well. But I think it's fair to say it's still not too many that are operating in this market, whereas the potential is actually it's huge. I mean, I think it's more or less a safe bet to say that in the next 20, 30, 40 years, this sector, this market will grow, will definitely grow. Hopefully it will grow, but because it would mean that this energy resource is tapped much more often than it is today. And again, just here, simple, I'm trying to explain it very simple how this works, and this holds true for heating and cooling. Please think both ways. If I'm doing my explanation now, always thinking about heating and cooling. It's basically just the difference is whether I'm extracting energy from the wastewater for heating purposes, or whether I'm using the wastewater as a heat sink, so I'm heating up the wastewater a bit for cooling purposes. I mean, this is now, well, this is a bit like the system that we are doing. One of the solutions that we have for heat exchangers that we're placing in the sewer pipe. But again, there are other technologies, there are other solutions. So you might, but the general principle applies here. You've got whatever heat exchanger there is, and you're placing this heat exchanger in wastewater, and you're either extracting the energy from this wastewater, or you're heating up the wastewater a bit, using it as a heat sink for cooling purposes. But what you can see here is, yeah, the heat exchanger extracts or puts some energy back into the wastewater, to say so, and then it is possible to continuously either supply heating or allow for cooling. This is because if there is a constant stream of wastewater, you can do it on a constant basis. Of course, if you would have not a stream, but like a pool of wastewater or whatever, then this is limited, because you can't reduce the temperature or the energy that you extract or that you would put in it. This would of course then be limited. But if there is a constant stream in the infrastructure, in the sewer pipe or at the treatment plant, you can use it for heating and cooling purposes. And of course, if you have this heat exchanger in the sewer pipe or next to the sewer pipe or at the treatment plant, you will need some sort of, you need a connection line. This is what we've got here in this little graphic in red. And this is a feed and return line to the heat pump. This is transporting this transfer medium. I mean, the idea of the heat exchanger is that you will feed it with, let's say, maybe a liquid that is 5-6 degrees in temperature, and then the wastewater is flowing over it or is surrounding the heat exchanger, and the wastewater is some 10 degrees. So then there's a heat transfer of this energy, of this heat, going to the transfer medium. This is maybe heating up or warming to 8 degrees or 9 degrees or whatever, and this is flowing back to the heat pump, and then the heat pump can use this, and you're using it, and this is using electrical power. Then the green and the heat pump could be a heating central for heat network, whatever. This graphic is just indicating little house, but think about a large scale heat pump here as well, that is maybe supplying a whole heating network or a cooling network. And then you use electricity to raise the temperatures of this transfer medium again to the desired temperature level that you need for the network or for the buildings. This is just, I hope this illustrated again how actually simple a system like this could look like, or looks like in principle. Of course, it's a bit more complicated when it comes to the heat pumps and so on, but it's in that sense, I think it's still quite simple. It's a simple solution. It's not rocket science, and it's actually, if you think about other renewable energy resources, something like this can be designed and built within rather a short time, I would say. I mean, I'm not talking about weeks from first idea to installation and running the system, operating the system, but we're definitely not talking about 5 years or 4 years or something like this before you can have a system that is using energy from wastewater for heating or cooling in operation. So in that sense, it's good news as well. if you have an idea for a project, you can start tomorrow. And if it's a promising one, it might be realistic to have this in operation within 2 years or so. It should work. And again, here, this is like for district heating and cooling networks, something that everyone is talking now about. I think it's right to do so because it's a very efficient way of providing heating and cooling to people. Well, there could be two possible ways how to use wastewater here. I took this graphic from the German Association of Heat Pumps, and I slightly adapted it to illustrate what I wanted to tell you here. Is that you can either you have a large heat pump, and this large heat pump is connected to a heating or cooling grid that is supplying buildings, customers, clients directly. This would mean that you connect this heat pump directly to the wastewater source. Could be here a treatment plant or sewer pipe. Or the other way is that you take the energy, or you take the on a lower temperature level from the wastewater and from the treatment plant. This you can see in the bottom of the graphic, and then you place little heat pumps in the buildings, raise the temperature there, or other way around, cool down the temperature there and feed it back into the network. This is many of you will have heard of this. This is always the question: what kind of temperature is more efficient in the network? If it's better to have a higher temperature already in the network, or if it's possible to operate the network pipes with a lower temperature. Of course, if you are having higher temperatures in the network, you might think about insulation and so on differently. On the other hand, it's at least this is the debate that we're having in Germany now. It's for many of the older buildings, it's a bit more complicated to operate on lower temperatures. Therefore, some of the networks are still running on very high temperatures. This is where it's then important to have a large-scale heat pump to reach these high temperatures. But if you can operate with the smaller heat pumps in the buildings, this is possible as well. Okay, I think this is I don't want to talk much more about this now. I just wanted to illustrate how wastewater can be included in these network systems. And I mean, this is we've done this in many projects, or we know that energy from wastewater is used in many projects in this or the other way. And so what are current challenges? I want to briefly say a few words about this, because I think these challenges, you will probably face them everywhere in the world where you will talk about this topic now, or where you might start a talk with local representatives, local stakeholders on this topic. I mean, first of all, we have to think about, we're bringing sectors together here, because we're talking about the water sector, water companies, and we're talking about the energy sector, energy companies. And these are really new partners at the table. They haven't done much business together in the past. And therefore, you will find a lot of information asymmetries, and we have different incentive structures. Let me maybe briefly explain this. I think this holds true for the water sector everywhere in the world. The water sector, the water companies in the first place, I mean, their job is to do wastewater management. They need to transport the wastewater to treatment plants. They need to treat the wastewater. They have to take care that the wastewater is then released again to rivers and to lakes and to the sea or whatever in a good state. So, I mean, this is their primary task, and therefore they are, first of all, not prepared to be now part of an energy infrastructure as well, maybe, where they are thinking about having their resource, having wastewater, and using it for heating and cooling purposes. So this is the water sector. First of all, it has a bit of a different incentive structure. On the other hand, our experience from wherever we go is that it's sometimes it's not that easy to convince stakeholders in the water sector that using the energy from wastewater for heating and cooling is a good idea. But almost any time our experience is that if you start to talk and if you explain it and if you show that the water sector can be part of the solution here for sustainable heating and cooling, and then usually everyone is opening up and is willing to talk this through and think about how it can, how projects can happen. But it is some way to go, and you need to well, you need to answer questions, valid questions, important questions that are there, because first of all, this infrastructure has been built for a different purpose. And if we want to use the wastewater infrastructure for heating and cooling purposes, then of course the water companies do have legitimate questions on how this is going to be done and how this is not harming the infrastructure in any way and so on. There are a lot of technical details. I would say they are not too complicated, so they can be talked through. I will not go into details here, but it's some talk that needs to be done. And yeah, then wastewater is a very local resource. This is what I said earlier. I mean, wastewater infrastructure in cities all around the world, it's right beneath our feet, and then it depends how this is organized, if it's a local company that is taking care of this infrastructure, or if these are larger companies, maybe countrywide companies that are taking care of the infrastructure. So these are of course questions or things to consider, but in the end it remains, it's a local resource, and therefore the local stakeholders, local governments, local energy companies maybe, and so on, they will need to think about how they can use this infrastructure, and they need to start talking about this. I think it's a good news for everyone who's now who wants to look into this topic in his city or in her city, and just start talking to people and making local people aware of this possible resource, and then think about with them how to possibly develop some projects there. And but a current challenge there as well, what we see is that policymakers are usually not very much aware of this topic of this renewable energy resource. I mean, this is at least what we are experiencing in all the countries that we are operating in. The good news is, once policymakers are aware of it, they usually are very much interested in this renewable energy resource, because I think they realize that it's an infrastructure that is anyway already there. They realize that there are no opponents to using this infrastructure. I wouldn't say that. I mean, the water sector, it can be an opponent, or it can be skeptical in the first place. But what I meant here is that if you're constructing a wind turbine somewhere, or if you're doing a geothermal drilling somewhere, all of us know that sometimes, there are citizens that are complaining about this installment or about the drilling or whatever. But with using wastewater, usually, I mean, no one is really against using wastewater and the energy from wastewater. So therefore, policymakers that we are talking to are, once they understand the topic and they see the topic, they are very much open to the idea. But it's few of them that know about this renewable energy resource, and we still think that it's important that more policymakers are as well aware of this renewable energy resource, because of course they've got the power and they've got the possibilities maybe to set framework conditions right, to talk to the water sector, talk to the energy sector, bring these stakeholders together, facilitate dialogue and so on. These are, from our point of view at least, really key things that the policymakers can do, and we always encourage them to do it much more, to arrange for stakeholder dialogues and to bring people really together around this topic, because this is what is still needed in many places where we are doing projects. And finally, Sastri asked me to then share some information on what might be good conditions to do a project, and even show one of our recent projects. Again, I have to say here, I mean, this is a bit focused on our experience, on our way on our technology, how to tap the energy from wastewater. But usually we would look at if you have a gravity sewer, there are pressure pipes as well. It's different sizes and so on. But I'm talking about the gravity sewer now, first place, and this would be, we say we start with a pipe size of 800 millimeter, 80 centimeter, to where usually, I mean, you will find enough wastewater a constant stream of wastewater in a size, a pipe of this size, then it makes sense to tap the energy there. Or of course, you can always have a look at the wastewater treatment plant, especially at the effluent of the treatment plant. So this is the part before the wastewater goes back into the river or the lake or the sea. No one actually, usually no one has something against tapping the energy there. In fact, it could be beneficial if the temperature of the wastewater, of the cleaned wastewater, then is cooled down again a bit there, because this is better for the animals, for everything, for the biology in the river. If the water that is fed back to the river, to the lake, and so on, it's not too warm. And then, yeah, we need a constant flow rate. This is what I said before. We usually say, well, we need at least 10 liters per second of dry weather flow rate. This is really important to consider, that we're not talking about rainfall or the water of rainfall and so on. We are looking really at just at the dry weather flow. So this means all the water that is used by people in the city, by industries, businesses, and so on, and just discharged in the sewer infrastructure. And this is what we are looking at, because this is the predictable stream, to say so, and we need a constant flow there to tap the energy. Otherwise, it wouldn't make sense if, for instance, during the nighttime there's no wastewater at all in the infrastructure. Yeah, so this is in a way, it's a bit limiting towards where you can do these projects. You would probably not find a sufficient amount of wastewater in a very little village, I'd say. But it's, on the other hand, if you see the picture here, it's a project we've done in the city of Berlin. These projects are not only possible only in the city of Berlin. This is always important for us to point out, that it could be really much smaller cities, could be just like 20,000, 30,000 people living there. Already those people, they will produce enough wastewater to find at least 1 or 2 sewer pipes, or maybe to have a look at the treatment plant of this little city, this little village, and see if you can do a project there. And then, of course, distance matters between the place where you tap the energy, or where you want to use the infrastructure as a heat sink. I mean, the distance matters because you need this connection line, which I showed you earlier in this other graphic. For instance, some of the treatment plants, if they are far outside of the city and you're thinking about the heat network in the city, it might still make sense to even do a connection between this treatment plant and the heat network in the city that is maybe many kilometers long. It could still be efficient. It will always depend on the project, if it is profitable for those that are developing the project. But now for the project that we have done, at least we see that it's usually up to a kilometer maybe. It's profitable, but this will change. I mean, if you're doing larger projects, and it might even be profitable to do a longer connection line. Well, on the demand side, it's what I said, I think already as well, is that we're looking at larger building complexes, 20 residential units upwards. We're looking at, of course, district heating and cooling networks. And where the lower the temperatures in the heating system, of course, the more profitable or more efficient the projects will be, because then you need less electricity for the heat pumps to reach the temperatures. If heating and cooling is done at the same time in the project, or in one project, heating in the winter time or in the colder time of the year, and cooling in the hotter time of the year, this is of course beneficial as well, because it's more hours of use, and then there's a competitive advantage of this rather warm renewable energy resource than, for instance, just using a heat pump with air. Yeah, these are just some of the some of the framework conditions I wanted to share. And then finally, just quickly showing here a project that we've done, where we've really heating and cooling is done for a whole quarter redevelopment happening in Berlin. The wastewater infrastructure here, the sewer pipe, you can see it on the right, where we've already installed some heat exchangers. I mean, this is still during the construction phase, so this will look different once the system is in operation, because you won't see it then anymore, because there will be wastewater all over it all the time. It's a large sewer, of course, here, I have to admit, but it's quite an interesting project, because we are providing heating and cooling up to 750 kilowatts here each to this quarter, and they would use PV to provide the electricity mostly for the heat pumps. So all in all, this is going to be quite a green concept or green quarter. And then they have a small scale heating cooling network that is connecting the different buildings of the quarter. Yeah, and I think that's already it. My contact details you can see here. I think they will be in the presentation, or can share the presentation afterwards as well. And I'm very much open to any questions now. Yeah, thanks.
Thank you, Christian. It was informative and insightful. I'm sure our attendees found the discussion on wastewater heat recovery, its applications, and the highlighted policy recommendations for the national level at the regional level also very interesting. For our attendees, please feel free to submit your questions in the Q&A session or raise your hand and unmute to ask a question directly. I would like to start with a question. What are some of the typical challenges that you face when engaging communities in energy conservation projects, especially in the context of wastewater heat recovery?
So well, the challenges we face. I'm looking at the questions and sessions as well here, so we can answer some of the questions as well. Well, the challenges you face is I think it's a lot about the stakeholders. To be honest, I think some of those that are here in the audience as well, who are working on these projects as well, they could probably talk about this all day. How difficult it can be to really to get the different stakeholders, water sector, energy sector, those that are developing the projects in the end, property developers and so on, get everyone at the table. I mean, I think this is true for other renewable energy resources as well. It's not easy to do a geothermal project. It's not easy to do, don't know, a solar thermal project or so on. You always need a number of stakeholders that need to work together. And this is probably this is the daily business challenge to really get people on the table, at the table, to talk things through with them, to convince them that they can do a project together. And in the end, I mean, this is something that we are not that much involved in. The end, for someone, this is the whole thing needs to be a business case, and these business cases, they are complex. This is what we realize. So this is a bit of the challenge, but therefore it's a project-specific challenge.
I would also like to pick up the questions from the audience. Some of the questions they asked is technicalities. What is the biggest number in terms of numbers they have been asking about it, and also how often the heat exchanger is cleaned.
Yeah, I see there quite some expert questions in the chat here. Well, I think the longest heat exchanger. I mean, when this would refer to a heat exchanger in the sewer pipe. It's few hundred meters. I think should be a few hundred meters that we have installed, and heat output is then close to a megawatt, something like this. Obviously, it's limited in the end how long you install a system in the sewer. But yeah, I think this should be it. And cleaning, well, that's always the question about cleaning the heat exchangers, because wastewater, of course, it's not like it's an aggressive form of water, and it's difficult to operate this infrastructure, and especially the materials you use and so on. Well, the cleaning of our heat exchangers, we say it's not really necessary, because it's stainless steel, and there's going to be a biofilm that is developing on the stainless steel due to the wastewater. But if you think about this while designing the plant, and knowing that this is going to limit the transfer of energy, the heat transfer, then you can design a system accordingly to already have this in the design of the system. And then if this is how at least for our technology, how cleaning looks like, and our systems are then cleaned if there's a heavy rainfall event. The velocity is very high of the stream in the sewer, then the systems will be cleaned a bit and so on. But it's not necessary to clean them on a regular basis. And then, yeah, Stuart, you've got a question on the operational sewer. I cannot have its flow diverted to another sewer upstream or over pumping? Yeah, that's a good question. I mean, I think to be honest, I think then you probably couldn't install a system there. I mean, if it's not possible to divert in the pipe, or if you pump it over, if you pump it outside and pump it back in. But I think, I mean, I would. The question for me would be really if this would be at all possible. I mean, if I mean, probably there are specific locations in the sewer where it's not possible, but hopefully in most cases it will be possible. And at least for the projects that we've done, it was possible to either divert the wastewater inside the pipe or to over pump it. And so if there are any other questions, happy to ask. I think there's another one. How about good coverage of district heating? Oh yeah, I think, yeah, this is a very interesting question. Thank you, about the district heating and where to connect. Yeah, if you have already have a good coverage of district heating, of a district heating system in the city, I mean, this is something that we now see in many cities where we are looking at projects, where the question, of course, is it's very much its location. I mean, as I said, if you have the treatment plant, the advantage of the treatment plant is that usually you can extract much higher amounts of energy there. So we are easily talking about megawatts that you can extract at the treatment plant. And if the treatment plant is not too far away to make the connection to the network, then it probably will be profitable and efficient to to do a large heat extraction, large energy extraction at the treatment plant, connect this to the heat network, and then this will probably the most profitable way or efficient way to do it. I mean, in the end, it's also about money and looking what is paying off for those that are doing these projects. But what we always like to point out is that we shouldn't forget about the sewer infrastructure, the sewer pipes in the city, because then again, location, it could be very close. It could be close to the heating network. The connection line could be close, which means less costs. So even if you may then be not able to extract like the 10 megawatt, the 20 megawatt, or whatever that you can extract at the treatment plant, you can even extract higher amounts at large treatment plants. Some interesting projects underway in the world there. But even if you are then maybe just able to extract a megawatt somewhere in a city, in an urban area, the location advantage might be huge, because it means much less cost for this connection line to the heating network. Or you can as well think about like local networks. I mean, some people always have this idea of a city being supplied by one large network, and there's this one large network that supplies every part of the city. But I think the reality or the future will be much more about many networks, local networks that are supplying maybe just 100 or 200 buildings or 1,000 buildings, and then there's the next quarter and there's the next network. And one network might operate on wastewater heat, one might operate on geothermal energy, another one on solar thermal, or you combine all of these. So building a lot of networks, little networks as well, I think this is probably the future for the networks. And then it's location, and the associated costs that come with the location that will probably decide whether it's best to tap at the energy at the treatment plant or infrastructure. In the sewer infrastructure, yes.
As you emphasize on the location, particularly, I would like to ask you one question regarding installing a geothermal extraction plant, power extraction, which is outside the city and located somewhat far from the city outskirts, and compare it with the heat recovery plant, which is inside the city, so which is near to the city's vicinity. So would you compare these two technologies, and what is the best for the city?
Well, I think every answer that I give here is probably could be debated. I mean, it's just very general. In very general terms, I would think about this. It's it's location. I mean, we know that. I mean, we have done some projects really in the heart of very busy city centers, and then what we learned is that people there say, well, we've got this building or we've got this quarter or whatever, and it's very good that we have this local renewable energy resource here that we can tap, because we don't have to think about doing a project outside of the city and then doing some pipe works to the city center and supplying a building there. I mean, I think in practice these options, they would probably not compete with each other. I mean, if you're doing a large-scale geothermal project out of the city somewhere where you can extract a lot of energy, then you probably already will think about feeding this into a large network that you're building and so on. So I think, the good news again is here we've got so many options on the table. We are just exploring all these options right now. I think we will not lack the options, and the question, if you're choosing this or this, will probably always depend on the calculations that will be made by those that are developing the whole projects, and they will see what are the investment costs, what are the costs of operation, and then they finally will have an idea what kind of system and resource they will choose. But I mean, as I said, the good news is what I realized during the last two years, during a lot of webinars and exchanges, is we've got so many renewable energy resources, and we've got so much potential there that we have no excuse for not switching to them. It's just a matter of prices. Of course, in places where oil and gas and so on is still very cheap, for all of these renewable energy resources, it's difficult to compete. But if the prices of oil and gas will go up, good news is we've got alternatives, and all of these can be profitable then in projects.
I would like to pick another question, if you allow me.
Mm-hmm.
What are the policy challenges that project developers and/or the project owners face upfront with respect to the policy making? What can local governments can immediately start doing, and where do you think national government support is most important?
Yes. Well, again, I mean, if I think about the other experts here in the room, they probably could share many good ideas and stories about how successful projects were happening and were implemented. I would say what we see right now, for instance, in what's happening in Germany, and what I think could as well happen in other countries as well, of course, and what is helping energy from the development of energy from wastewater, is that the local governments are now, what they need to do is as part of a bigger plan for the transition of heating and cooling, but part of this plan is now that the local governments, they have to analyze and map their wastewater infrastructure. So they will really, it's mandatory for them to come up with a city map, to say so, where they show where the wastewater, where the sewer pipes are, the larger sewer pipes are, where the treatment plants are, and so on, just to make it visible, to make this renewable energy resource visible. And this is then very transparent. So project developers, those that are developing heat networks, cooling networks, and so on, they can have a look at at location. We're talking about locations here, location, and see how what options are available. So just making this infrastructure more visible. This hasn't been done in the past. I mean, in some cities it has, but not in many cities, because of course the water sector in the past, they needed this information for the maintenance of their infrastructure and for connecting new buildings and so on. But the idea in the past has not been to use it for energy, for heating and cooling as well. So this is something local governments can do. They can, first of all, I mean, they can find out, is it actually myself that I'm operating this infrastructure, maybe as the local government or the local city council, and then I can gather the information on the infrastructure that I have, and I can, for instance, as well identify maybe good locations in the infrastructure, large sewer pipes where there's a lot of wastewater. I can have a look, where's the treatment plant? Is this maybe close to the city? So is it likely that I can extract energy there and connect it via a heat network to the city and so on? So this is what local governments and local authorities can do. They can look at this infrastructure locally. it's actually it's their resource, it's their renewable energy resource, it's the wastewater of their people. So therefore, I think it's I mean, to me, if I would work for a city authority, for a local authority, this would be quite an attractive idea to investigate this topic further. So this would be the local level. The national level, we think, and this is what we are asking politicians, for instance, in Germany as well, as we're just saying, please help to bring stakeholders together. Please help us to appeal to the water sector, to the energy sector, to come together at the table, because in the end, they will need to make some business together as well. They will need to agree on terms of use of this infrastructure and so on. Nothing that hasn't been done before. There are many good examples of how this can be done. But if you think about I mean, it still is so many more these stakeholders that have never heard of the topic than those that have heard and have implemented projects. As I said, market very early beginning. So policymakers on a national level, they can always help exploiting this renewable energy resource and using it by just mentioning that it's there, and by just addressing this to the water sector, to the energy sector, tell them, well, boys and girls, sit together and think about how you can use it for our renewable energy supply.
Yeah.
Yes. I think there's maybe one.
It's a comment on the.
Oh, okay. Okay. Yeah.
Yeah, thank you, Christian, for your insightful responses and expertise. I also want to extend my gratitude to all the attendees for participating in this engaging exchange. We have received many excellent questions, and we will make sure to reach out to you individually to provide answers via email. It's clear that there is a lot of interest in these topics, and we hope to replicate such exchanges in more cities and regions contexts. There is always more to learn and explore, especially when it comes to empowering communities, promoting renewable energy, and enhancing energy security while addressing energy poverty. We are planning future exchanges as part of this season, including the topics like future of energy efficient buildings and innovative financing mechanisms. Stay tuned to those exciting discussions. There are no more questions or comment. I would like to officially conclude today's energy exchange. Thank you all for your participation and valuable insights. I would like to share some of the links here. I encourage everyone to get involved with our work on 100% renewables. Feel free to reach out to us via email, and let's explore how we can support through our initiatives and work together towards a sustainable energy future. Your engagement is highly valued, and together we can make a positive impact. Next slide, please. I want to extend my heartfelt thanks to our Season 1 partners, R2M Solutions, Urban Shift, Schneider Electric, and Uhrig. Your collaboration has been invaluable in making this season a success. A special thank you to Christian for dedicating your time and sharing your expertise and insights with us. It has been a great learning experience for all of us. Next slide. As we conclude this exchange, let's take the knowledge and inspiration we have gained and channel it into our work to create the impact that our communities and the planet need. Thank you all, and I wish you a wonderful day ahead.